Hello, pre-calculus students. Today we're going to learn how to graph the tangent function and the reciprocal functions, the secant, the cosecant, and the cotangent. So let's take a look at this graph. This is the graph of y equals tangent x. You can see it has a period of pi because a period, again, is how long it takes before the graph repeats. And if you copy and paste, you get exactly the tangent graph. So this over here would be -3 pi over 2. There would be another asymptote here, just like there's an asymptote here at positive. I'll just draw it in. Make life easier. 1 pi over 2, 2 pi over 2, 3 pi over 2. So you can see that the period is pi. We know that tangent is y over x. So if you think of pi over 4 or 45 degrees, y on the unit circle, those would both be √2 over 2. So tangent is 1. So here at pi over 4, tangent is 1. At pi over 2, x is 0. So you have this asymptote. And you're going off to positive infinity here. As soon as you pass pi over 2, though, your x value is negative. So that's why it goes down to -infinity here and works its way back up. Where does this shape come from? Well, again, tangent theta is y over x. So I'll write tangent in orange here, so it'll stand out. So here the y value, if would be a 30, 60, 90, right triangle. This would be 30. The unit circle has a length of 1, so this y value would be 1/2 and √3 over 2. Well, 1/2 divided by √3 over 2 is 1 over √3, which is √3 over 3. So that's the tangent. Well, of course, the tangent here is 0 because y is 0. Tangent here, it's over, the y is √2 over 2, x is √2 over 2, r is 1. So the tangent is 1. Here we have a y of √3 over 2 and x of 1/2. So that's going to be a tangent of √3. And here we have an x of 0. So on this side, it's infinity. On this side of 90 degrees. At 90 degrees, it's approaching infinity. At 90 degrees, it's infinity or undefined, however we like to word that. And then over here becomes negative. Well, same thing down here, the triangles are the same. This -30-degree angle still makes a 30, 60, 90, just like this positive one does. So except the y value is negative, so this one's going to be -√3 over 3. This one's going to be -1. This one's going to be -√3. And this one down here would be -infinity. So that you notice that as we go from -90 degrees or negative pi over 2, we start at -infinity, work our way up. The numbers are getting bigger, bigger, bigger. Here it gets to 0, and they still get bigger, 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 and it goes to positive infinity. Here at -90 degrees or negative pi over 2, we're approaching -infinity. Graph gets bigger, bigger, bigger. At 0, the tangent is 0. And then as we approach pi over 2, we get to positive infinity. Then as soon as we cross pi over 2 here, now our x is negative, so y over x, positive over negative would be negative. So down here it starts at -infinity and works its way back up again. So that's where the tangent graph, this is what it looks like. This is where it comes from, keeping in mind that the tangent of theta is y over x. So just like we had the generic sine and cosine equation, now we have a generic tangent equation. So where are the asymptotes? You set x equal to negative pi over 2 and pi over 2 because, there's my graph. That's where the asymptotes are at negative pi over 2 and pi over 2. So now remember, this c value is going to horizontally translate the graph. So if you just set bx minus c to negative pi over 2 and to pi over 2 and solve for x, you'll get your asymptote of your phase shifted graph. Also, the period of this is not 2 pi over b, as it is for sine and cosine. It's pi over b, because tangent only has a period of pi. Now let's take a look at the reciprocal functions. So secant is 1 over cosine x, and we're not going to spend a lot of time stretching, reflecting, and translating these reciprocal functions. So secant is 1 over cosine. So what I did is I kind of drew in, I dotted in a cosine curve here. And now I'm just going to take the reciprocal of all these values. Well, here the reciprocal of 1 is 1, so those graphs touch there. And here we're getting smaller and smaller and smaller, approaching 0. So 1 over 0 would be infinity. So here we're going to get the reciprocal then would be getting larger, 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 approaching infinity. Here we're getting smaller and smaller and smaller, approaching starting at 0 and going to negative 1. So when we take the reciprocal of 0, again, it's going to be infinity, but we're on the negative. It won't ever be infinity. So the moment we go a hair's breadth to the right, it will be negative. And it's going to, if here we're getting smaller, smaller, and smaller, approaching 1. The reciprocal of 1 is 1. So this must get bigger and bigger and bigger and approach 1. The two graphs kiss at that point. Then this gets bigger, this gets smaller. So you can see that to graph the secant function, the easiest way is to graph cosine and just think, what's happening to these values as I take the reciprocal of them? And of course, the period, if cosine has a period of 2 pi, secant is going to have a period of 2 pi. Cosecant is the reciprocal of the sine function. So again, I've drawn a sine, one period of the sine function. And I just do the same thing. 0, the reciprocal would be infinity. So this graph must be, here we're getting closer and closer to infinity. Getting bigger and bigger, approaching 1. The reciprocal of 1 is 1. We're getting smaller and smaller and smaller and approaching 1. Graphs kiss there at pi over 2, 1. Then this gets smaller and smaller and smaller. This gets bigger and bigger and bigger. So when this hits 0, this would hit infinity, but you can't get to infinity. That's why it's an asymptote. Same down here. So draw the primary function and then do the reciprocal. Cotangent. In black, let's see, I've done the asymptotes at negative pi over 2 and pi over 2. I've drawn a second period of tangent here. You'll see why. So we go from negative pi over 2 to pi over 2. That's one period of tangent. Pi over 2 to 3 pi over 2. That's another period of tangent. Now let's start doing the reciprocal. Well, wherever x is 0, wherever tangent is 0, the reciprocal is going to be infinity, so that's going to be an asymptote. So the tangent is 0 here. There must be an asymptote for the cotangent. There's another tangent equaling 0 here, so I have another asymptote here. At pi over 2, tangent is undefined. It would be infinity. 1 over infinity is 0, so you get to 0 here. At pi over 4, tangent of pi over 4 is 1. 1 over 1 is 1. So that's why both the tangent curve and the cotangent curve touch here at pi over 4, 1. And so anyway, if you keep playing with the numbers, you get this curve. Why didn't we go over here and over here? Well, we do one period of the graph. We always like a period to include 0. And why do this piece? Why do a piece over here and a piece over here if we could just make one continuous graph? Here, you see the period is still pi as we go from 0 to pi. It's just that we didn't have to do a piece here and a piece here like we did on the secant graph. See how I did a piece here and a piece here? Just easier, to do this one continuous curve. So one period of cotangent is still pi. We just graph it. Generally, we graph that primary period from 0 to pi. Just like in tangent, we normally graph it from negative pi over 2 to pi over 2, just so we have that one continuous curve. Otherwise, if we went from 0 to pi, you see we just have to break it up into 2 pieces. And there's no sense in doing that if we can avoid it. So 3 secant theta, 3 times secant theta. So I draw my cosine, I do 3 times the cosine of theta. And then, so I got 3 here and negative 3 here. And then I do my, curves. Go see this getting smaller and going to 0. This is going to get larger and go up. Now you might say, well, why isn't it 1/3? Because it's not. This isn't 1 over 3 times cosine theta. It's 3 times 1 over cosine theta. So if cosine theta is 1, 1 over that is going to be 1 times 3 is 3, and then it'll work up here. Now, if I wanted to phase shift this and graph this curve, and again, I don't want to get into a lot of that. We know that cosine, let's see. Oh, we're going to set it from cosine. We normally graph from 0 to 2 pi. So we're going to set 0 to 2 pi here. So pi x minus pi over 4 will equal 0. X minus pi over 4 will equal 2 pi. Solve for x, and that's where these asymptotes will move. You'll see the first one would be x equals pi over 4, which makes sense. We've replaced x with x minus pi over 4. It should shift everything pi over 4 to the right, or for your view, to the right. And so, let's see, what am I doing? Oh, no, I'm sorry. Those aren't asymptotes, my bad. Where we find these minimums, so where cosine is a maximum at 0 and 2 pi, brain cramp early in the morning, where cosine is a maximum at 0 and 2 pi, you would solve for x, and that's where your new cosine maximum would be. So if we shifted this pi over 4 to the right, we'd shift this point here on the cosine curve, pi over 4 to the right, and that would also move the secant curve pi over 4 to the right. And that's where our cosine, that's where our maximum for cosine would be, and either the relative minimum or relative maximum, depending, for the secant curve. So we've learned to graph tangent. To me, it is important that you know what a tangent curve looks like and how we got those numbers. The other 3 functions, I just want you to know how to graph them from the primary function. So in order to graph secant, I want you to know that you graph the cosine curve, then just start taking reciprocals. For cosecant, graph the sine curve and start taking reciprocals. And for tangent, or for cotangent, graph the tangent curve and take reciprocals. That's all I've got for this lesson. Have a great day.